Hello everyone, good afternoon. I'm Professor Sonali delivering the very first lecture, technical lecture on basics of cryptography. Here I will cover such topics like introduction to the cryptography, then what is encryption and decryption, basic terminology, what are used in, then we'll see some basic examples. We'll also see importance of public-private key encryption here, and at the last we will see what are the real-life applications of cryptography. Before jump to our main topic, let's discuss something. Basically, the word encryption and decryption are quite familiar to us. You may already know these words and may be used in daily life. Before jumping to the encryption, we will see how do our messages travels through internet. There is a local internet service provider communicating with regional service provider, followed by network service provider, and then the final destination. We know our data from mobile or web. These data are travels in packets and it take any path through any different routers to reach the destination, and in general we assume that our ISP, that is internet service provider, don't easily drop our connection or communication. Let's get some real life example. When we are connecting to the public Wi-Fi, hotspot in restaurant and any shopping malls, we have to be very cautious that whoever installed the hotspot is unable to see that we are browsing. Many of us know the prefix, basically HTTP and HTTPS, being shown you and our addresses. These are internet protocols, and S represents communication is secure. For secure communication, access point provider won't be able to know other than that we are accessing the sites. They can't see our logins, they can't see which page we are looking at or anything else. And here the main encryption rule comes. So these all connections, all communications are encrypted. Let's jump to one kind of example. Here I have take one example, a simple plain text. It is called a plain text, HELLO, that is hello. Now you might surprise, what is these numbers? Now these numbers are nothing but ASCII numbers. These are called ASCII code or ASCII number. So H for 72, E for 69, L for 76, and so on. Now how encryption will work here? One particular value or one particular key will be used to generate a public key. Okay, now public key, cipher key, private key, are these all are terminology using in encryption. So here key is plus. If you might see, this is a 1. So here 1 is key. Generally this key will be a public key. It means this key will be applied to this plain text. So you can see the answer of this, that 72 plus 1 73, 69 plus 1 70, and so on. So here we generate some different words. We see a different letters. Yeah, as 73 is a ASCII code for I. Here 70 is the ASCII code for F. Here 77 ASCII code for M. So likewise this, we generate some different alphabets that we don't know. This is a plain text or this is the original message called hello. Now this is called encryption. Now we turn to the next part, that is a decryption. Now we know if sender receives this text, so how can that receiver will get a original text. So here we will use the same key. You can just you just see my words. I am saying that using a same key. So as for the public key we have used 1, so here also we have to use 1. Now when both keys are same, that will be called a encryption. That will be called a symmetric encryption. Okay, we will look into that next. So what happened when we say a -1? Okay, so as we know, 73 minus 1 is 72. 70 minus 1 is 69, and so on. So finally we will get some different digits, that is this, and this is nothing but your plain text. And only the receiver who knows the key can decrypt this message. So here receiver will hold its private key and the sender will have some public key. I will jump into what is this private key and public key later. Now we'll see what is cryptography. The cryptography is nothing but the study of secure communication. As we see earlier, there are two recipients, there are two players, that is, one is sender and one is a recipient. In the previous example we have seen that hello text is sent by some sender and it is get converted into something called ciphertext, and then that encrypted form will received by the recipient. Now this term is originally from the Greek word, and that Greek word is called a crypto. So crypto is nothing but a hidden. Okay, so it is closely associated to the encryption we have already seen, which is the act of scrambling ordinary text into what's known as a ciphertext and then back again upon normal. We have seen. Now encryption and decryption means that encryption refers to coding of information in order to keep it secret. The encryption is accomplished by transforming the string of the character, compromising the information to produce a new string. That new code is called a ciphertext and may be safely stored or transmitted over the network. At a later time, it can be deciphered by reversing the encryption. This process to recover the original information, which is called the plain text. Some terminology we have to always use while studying the encryption or learning the encryption. That is, first is the encryption, cryptosystem, then what is the plain text, then what is the ciphertext, and what is a decryption, or what we can say a deciphertext. Here let's get into some imaginary scenario. Just suppose that one person have to send a confidential document, and that will be locked in one briefcase, and before sending it to the destination, what happened in between this? Suppose in this picture, here it is one girl and one is boy. So one lady or one girl is sending a secret message or confidential message to this boy. So here we refer this girl is a A and this boy is a B. Now what happened? A theft or transporter not possible to access the document. Only the receiver with the key to the briefcase be able to open it. In this scenario, B will have some key that is called the private key. Now here comes the major role of key distribution center. So key distribution center is act as a server. It has all the responsibility of transferring the key from sender to receiver. Now if receiver uses the same key to open the briefcase, is called the symmetric encryption. Now this is the scenario which is called asymmetric encryption. Yes, there are two types of encryption, symmetric and asymmetric. Now asymmetric encryption has two different keys. As you can see here, it is one receiver and one is sender. So we'll jump to the same scenario before. If what key will be stolen? So to overcome this issue, we have to look an intelligent locking system here. So here basically each user has two keys. User has to submit one key to the key distributor center, that is on server we can say. It means that one key is a publicly available always, and that is called a public key. So if we see this picture, this sender has already been stored its public key in key distribution center. Same like that, this receiver also save its public key or her public key on the center. Now what next? However, nobody will be shared the other key, which is a private to each of the user. It means here the sender, it will have a two key, a receiver will have a two key. So sender will submit its public key on server and kept one key with him, that is a private key. Okay. So here the most important system is a lock. Yes, the picture shows that it is an original lock in daily life we have used. So what I'm discussing here, that lock can be closed using any key, right? The same key could not open the lock. The first scenario is if the traditional lock and we have a key. So by the same key, yes, we know that by the same key we can lock the key and unlock the key. But in digital world, what happens? If you lock something by the public key, you cannot reopen using the public key. Okay, you will clear this all in the next few minutes. Now to open it, you have to use a corresponding private key. So in this scenario, one lock will be there, two keys will be there. One will be the private key, one will be the public key. It means private key, by private key you can unlock it, and only the public key will get help to lock your lock. Okay, so even no other users, no different users private key or public key cannot able to open this lock. Means, for example, every message, every text, every single message will be get encrypted. So nobody will see, only the receiver can see that message. So here in this scenario, just suppose a sender A wants to send a box to B, which is a recipient or receiver. Actually, A requests a public key of B from key distribution center, and then key distribution shares the public key with A, and then she locks the box. Now if we see this picture, this receiver and this sender will have to communicate with each other. So what happened? When sender send this plain text, first this person will request the public key to the receiver. So he has to get a public key of this receiver from the KDC. So by applying this public key to this particular message or plain text, it will get encrypted, and by encrypting it will be sent by the network. Now in between, what happen if some malicious user, that is a hacker, can want to hack, because this public key is available. Just understand. So if public key is available here, but by the public key not any kind of a lock will going to unlock. So like that, message also cannot be converted into the original one. So by sending this from sender to receiver, this person is get this message and she will get the message which is original one, and that is will get decrypted by a secret key. Now this secret key is nothing but this person's key. So here public key is of her, secret key is also of her. Only the sender will request the public key before encryption of this receiver. So in this picture you can just see she is asked, please encrypt the data for sending me by using public key. So as this person requests to her for the public key of her, this person is requesting the public key for her, and she is already submitted her public key on the web. So same scenario we can see in the digital world. Now thank you so much for watching this video.